Dear friends, welcome to Infos. Welcome to another video from Infos. We are now continuing our session on valves. In last video, we have completed valve part 1, the basics of valves and classification of valves. Some more classification is pending in this video. Plus another thing is valve characteristics and other information in this video. Welcome to this video. Classification according to motion. Another two type of valve classification is linear and rotary motion. So that we will see how valve is classified in that category. Classification of valves according to the mechanical motion of the valve. Linear motion valves, also commonly called linear valves, have a sliding stem design that pushes a closure element into an open or closed position. The term closure element is used to describe any internal valve device that is used to open, close or regulate the flow. You can see from this picture, this is a gate valve actually, linear motion valve. It is vertically moving, the opening and closing element is vertically moving. You can see here the valve is fully open here and this is the flow path. So in this coming here, you can see here the valve is completely closed, not fully closed. So this is the flow path. So this is a simple, very good representation for a linear motion. Valve 1 is a gate valve. Another one is, you can see here, it is a plug valve. It is also linear motion valve. The stem is opening element or closing element is moving up and down. So it is a linear motion valve. So this is the flow path. So just to pause the video and watch this one carefully to understand this one. So this is a linear motion valve and any internal device that is used to open, close or regulate the flow. That is a linear motion valve. Globe, gate, globe, pinch, diaphragm, split body, three-way and angle valves are all fit into this classification. Linear valves are known for their simple design, easy maintenance and versatility with more size, pressure class and design option other than motion classification. Therefore, they are the most common type of valve in existence today. So that this is the most common type of valves, linear motion valves. These all are coming under gate, globe, pinch, like diaphragm. Some valves picture is not available, so most of them are here. If you get time to permit, visit your field. Next time you visit various valves, understand with P and ID. So what are the different symbols using that one, and in the field you identify physically how it is, what are the differences there, just to identify that one. So that will give a very good experience on understanding valves. Rotary motion valves. Rotary motion valves, also called rotary valves, can closure element that rotate through a quarter turn or 45-degree range to open, block the flow. These are the rotary motion valve. In this one you can see this is a ball valve. So the handle is here, this is the handle. So it's a quarter turn. So it is a 45-degree to 90-degree quarter turn. It will close and open. Rotary valves are usually smaller in size and weight less than comparable linear valves. Size for application wise, they are limited to certain pressure drop and prone to cavitation and flashing problem. So application wise, they are limited to certain pressure drops. However, as rotary valve designs have matured, they have overcome these inherent limitations and are now being used at an increasing rate. So this is a rotary motion valve. One more classification is there, classification according to port size. These are the advanced level of classification. In normal level, in the basic information, these are not much important, but we are covering valve in full details of valve module. So I thought that one we have to cover all necessary information. Another classification is valve classification according to port size, full port valve. In process system, most valves are designed to restrict the flow to some extent by allowing the flow passage way or area of the closer element to be similar than inside diameter of the pipeline. Look at that one here. Full port means the flow path is actually full port is there. Some other case it is the reduced port is there. That's why this is a full port valve. So these are the another classification. Closer element to be smaller than inside diameter, but here it is not like that one. It is equal diameter than the flow path. On the other hand, some gate and ball valves can be designed to that so that internal flow passageways are large enough to pass flow without significant restriction. In this case, it is not full path, no significant restriction. Such valves are called full port valves because the internal flow equal to the full area of the internal port. So this is the classification of full port valve according to the port size. Full port valves are used primarily with on-off blocking device. We have already seen on-off type classification in our video number valve number 1. I request you to watch that one, and I will attach in each video, end of the video, as a card I am attaching the playlist, entire playlist, so you can select your suitable video when I am discussing or referring some information on previous videos. Where the flow must be stopped or diverted. Full port valves also allow for the use of a pig in the pipeline. The pig is a self-cleaning facility, cleaning tool, self-driven mechanism designed to score inside the pipeline to remove any process buildup or scale. We have completed pigging process video separately. So in the playlist it is attached or included here, and request you to watch that pigging process. So this is the full port valve. Ball valve is full port valve, butterfly valve also. Some valves are considering in full port valve. Reduced port valve is there. You can see from this one here. See here, this is the full bore. Complete bore is there, but here it is reduced bore. Here also you can see full port and standard port or reduced port. Reduced port valves are those valves whose closer element restrict the flow. The flow area of that port of the closer element is less than the area of the inside diameter of the pipeline. For example, the seat in linear globe valve or a sleeve passage in a plug valve, senior passageway in a plug valve would have the same flow area as in the inside of the inlet or outlet port of the valve body. This restriction allows the valve to take a pressure drop as flow moves through a closer element, allowing a partial pressure recovery after the flow moves the past restriction. So this is the concept on reduced port valves. The primary purpose of a reduced port valve is to control the flow through reduced flow or throttling. So it is the application is mainly on control valve, which is defined as a regulating the closer element to provide varying levels of flow at a certain opening of the valve. So main application is in control valves application. Reduced port valves are concept classification is using. Another important information of the valves module, we have to coming on common piping nomenclature. The valve industry, along with a good portion of the process industry, has been driven by developments and companies originating in North America over the past 50 years. Valve and piping nomenclature has been heavily influenced by imperial system, which uses such terms as pounds per square inch, that is PSI, to refer to pressure or nominal pipe size, to refer to refer to valve and pipe size in inches across the pipe inside the diameter. These terms are still in use today in United States and are based upon the nomenclature established by the American National Standard Institute, ANSI. Outside of the US, valves and piping nomenclature is based on the International System of Unit metric system, which was established by International Standard Organization. So mainly the nomenclature is explaining about in American side and European side. This is the difference. One is in metric and one is in SI system, ISO system. According to metric system, the basic unit of measurement is a meter, and distance are related to kilometers and equal to a meter, millimeter, centimeter. Typical metric value of measurements are called in millimeter, and pressure are noted in kilopascal or bar. So this is the difference in American system PSI, and here it is bar or kilopascal. So that is a difference. So such way that nomenclature, piping nomenclature is included. ISO standards refer to pipe diameter as nominal diameter and pressure rating as nominal pressure. Now one important information section is coming on valves. Valve selection criteria. There are some few criteria are using, characteristics are using for a suitable valve for a suitable operation. So each application, each operation is different, valves are using that one. So in that one we will quickly go through. Number one is valve coefficients. This is a design parameter. In application wise, we never think about, at least in operation level, never think about a valve coefficient. Let us understand the information, it is good for us. The measurement commonly applied to valves is the valve coefficient CV, that is the short form, which is also known as the flow coefficient. When selecting a valve for a particular application, the valve coefficient is used to determine the valve size that will best allow the valve to pass the required flow rate while providing stable control of the process fluid. So it is very important selecting for a particular valve. We have to consider the valve coefficient, how manufacturer is considering this value. Valve manufacturers commonly publish CV data for various valve style which are approximate in nature and can carry usually up to 10% according to the piping configuration and trim manufacturer. If CV is not calculated correctly for a valve, the valve usually experiences diminished performance in one of two ways. So it will, CV calculation is very much important, otherwise performance will affect on a valve in the application side. The CV is too small for a required process, the valve itself or the trim inside the valve will be undersized, or the process system can be starved for fluid. In addition, because of the restriction in the valve can cause a buildup in upstream pressure, higher back pressure created before the valve can lead to damage in upstream pumps or other upstream equipment. So in addition, because restriction in the valve can cause a buildup in upstream pressure, higher back pressure created before the valve can lead to damage in upstream pumps or other equipment. So the CV calculation or CV suitable application will affect the performance in each area. Undersized CV can also create a higher pressure drop across a valve, which can lead to cavitation or flashing drop, and faster velocities causing cavitation, flashing, erosion of the trim part. So many problems can arise if the CV calculation is not correct or suitable to process application. In addition, if the closer element is closer to the seat and the operator is not strong enough to hold that position, it may be sucked into the seat. This problem is appropriately called the bathtub stopper effect. So that is a good word to keep in mind. So second characteristics or second criteria for valve selection is flow characteristics. Let us see how the flow characteristics is discussing. Each throttling valve is mainly control valve, has a flow characteristic which describe the relationship between the valve coefficient CD and the valve stroke. In other words, a valve open, as a valve opens, the flow characteristic which is an inherent to the design of the selected valve allows a certain amount of flow through the valve at a particular percentage of stroke. So when the valve is opening, the slowly opening, when the initial time the slow opening, the middle time stabilized flow, and in the end side it is established flow, like that one, a particular percentage of stroke. So this attribute allow the valve to control the flow in a predictable manner, which is important when using a throttling valve. See, this is the throttling valve. So in the throttling valve, the seating or zero closing will be tight close should be required. Opening will be very slow and closing will be fast as much as possible, and predictable manner. 50% open command is coming from the controller. 50% should valve should open in a predictable manner, means perfectly, not 49 or 51. So this type of flow characteristics describe that relationship. So it is important for in type of throttling valve. Let us see how it is considering these characteristics. The flow rate through the throttling valve is not only affected by flow characteristic of the valve, but also some pressure drop across the valve. Definitely that also considering that one. A valve flow characteristic acting within the system that allows a varying pressure drop can be much different or can significantly from the same flow characteristic in an application with a constant pressure drop. When a valve is operating with a constant pressure drop without taking into account the effect of piping, the flow characteristic is known as inherent flow characteristic. So this is the one information to pass that one. When a valve is operating with a constant pressure drop without taking to account the effect of piping, the flow characteristic is known as inherent flow characteristic. However, if both the valve and piping effect are taken to account, the flow characteristic changes from the ideal curve and is known as installed flow characteristic. So inherent characteristic is the design condition. The manufacturer and the vendor is design people are recommending. So design people designing that one. But when installed condition, piping effect, pressure drop, tear and wear, or many conditions are considering, then we are getting installed flow characteristic. Let us see that one, how both are working on it. Some rotary valves such as butterfly and ball valves have an inherent characteristic that cannot be changed because the closer element cannot be modified easily. For this reason, rotary control valves in a throttling application can modify this element characteristic, then this inherent characteristic, using a characterizable cam with an actuator positioner by changing the shape of the closing device, such as a V-notched ball valve. I have completed one video on positioner, requesting you to watch that one positioner in instrumentation control section. Quarter turn plug and valve valves can modify the characteristic by varying the opening of the plug. We can attach the plug valve picture here. So this inherent characteristic slightly we can modify with this type of plug valve by opening the plug, varying the opening the plug. So some modification also possible in this characteristic modification. On the other hand, linear valves usually have a flow characteristic designed into the trim. In linear valves, they are modifying the trim opening by determining either the size and shape of the holes in a cage or shape of the plug head. This way, this is the picture representing that one, linear, fast opening linear. This is we are going to discuss. So adjusting the plug and trim size, shape and size. So the three most common type of flow characteristics are equal percentage, linear and quick open. So linear is the ideal one in the center and quick open is the fast opening. Some special type of valve it is fast opening, and equal percentage is the below linear level. We will just to go through it and understand what is the what is quick opening characteristic, linear one and equal percentage. We will see one by one. These are the graphical representation. These are the opening element, mechanical adjustment or shaping, linear, equal percentage and quick opening. These are the representation, better a clear understanding. However, the inherent characteristics of these curves can be affected by the body style, design and piping, etc. So all the factors can affected in the inherent characteristics. The first one is equal flow characteristics. This one we are discussing, equal flow characteristics. See that one, the equal percentage characteristics is most frequently specified with the throttling valves on, that means a control valves. So the graphical representation is the ideal one is here, and this is the equal percentage opening. The equal percentage characteristics, so mostly in throttling valve, with an equal percentage characteristics, the change in flow per unit of valve stroke, that is this one, is directly proportional to the flow occurring just before the change is made. With an inherent equal percentage characteristic, the flow rate is small in the beginning, here this area of the stroke, and increases larger magnitude when the end of the stroke. See, in the larger magnitude in the end of the stroke, stabilization in the center stage. So these are the equal percentage flow characteristics, but in actual condition affecting on pressure or piping effect and etc., some changes are coming here. This provides good exact control on closure element in the first half of the stroke, where control is harder to maintain because the closure element is more apt to be affected by the process forces. So in the beginning of it is first half the stroke, extract control, you can get it a tight shut off and or slowly open. On the other hand, unequal percentage characteristic provide increased capacity in the second half, this area of the stroke, allowing a valve to pass the required flow. An equal percentage characteristic result in improved rangeability for a particular valve, as well as better repeatability in and resolution in the first half of the stroke. These are the advantage of equal percentage flow characteristic. But in actual case, the practical case, although the flow characteristics of the valve itself is equal percentage is here, the installed flow characteristic is closer to the linear flow. See, it is inherent one and installed one. Inherent is equal percentage is below linear one, but the installed one, the practical case depend upon the piping effect and other parameters. See, it is sometimes crossing or it is moving away from equal percentage and moving towards to linear one. This is usually the case when the process system pressure drop is larger than the pressure drop across the valve. So many parameter is affecting or to change this flow characteristics. The inherent flow characteristic and the installed characteristics that take into account piping effect also. one of the reason. The addition of piping effect has a tendency to move the flow characteristic away from the ideal equal percentage characteristics toward the inherent linear one. Second characteristic going to discuss on a linear one. This is the linear one. We have completed equal percentage. The inherent linear flow characteristics produces equal percentage, produces equal changes in flow per unit valve stroke regardless of the position of valve. So equal percentage opening when the valve is moving and the opening also same, the production or percentage of CV also moving exactly in equal percentage, equal changes is taking place. Linear flow characteristics are usually specified in those process systems where the majority of the pressure drop is taken through the valve. So this one is usually specified in those process systems. The majority of pressure drop is taken through the valve. For the most linear flow characteristics provide better flow capacity throughout the entire stroke as opposed to equal percentage one. So it is a better flow capacity can provide in linear flow. But figure shows the inherent flow, linear flow characteristics. This is the inherent one, but the installed characteristics take into account of piping effect. As we can see by this figure, the piping effect have a tendency to push linear flow characteristics toward to quick open to another one. See, linear flow also modified linear, it will move to quick open. So in the previous one equal percentage also moving to, in the practical case and installed case it is moving to linear. In the linear, in the practical case and installed case it is moving to another one, quick opening. These are the flow characteristics. The third flow characteristic, quick open flow characteristic. Let us understand that one. This is one, linear is here, quick equal is here, quick open. It is fast opening and establishing the flow quickly. Fast opening, see, without the valve lifting and quickly opening, taking to the established flow. The quick open characteristic is used almost exclusively for on-off application. On-off application mean ESD valve is on-off application either in on position or in off position. Off position is very fast, that is shut off position, and open position is slowly. But here there is some difference is there, fast opening, where the maximum flow is produced immediately as the valve begins to open. Because the extreme nature of the quick open characteristics, the inherent and installed characteristics are similar. In this case, the inherent and installed characteristic, no moving towards to other one, it is almost same in this case. Extreme nature of the quick open characteristic, the inherent and installed characteristics are similar in this quick open flow characteristic. The third valve selection criteria is shutoff requirement. Shutoff standards, let us look that one. Industry standards have been established for the control valve industry regarding the amount of permissible leakage of the process fluid through a valve seat or seal. So the shutoff, how much is permissible leakage? In that category also valve is categorized in various valve selection criteria. Usually this standard is applied to throttling valves, but may be applicable to other types of valve also. Specifically ANSI standard 70-1976 or reaffirmed in 1982 provides the outline of 6 classification of shutoff. So 6 classification is mentioned in various application, leaking allowance, providing that one shutoff requirement. Let us see that one by one. Shutoff classifications are determined by a percentage of a test fluid, usually water or air, that passes through the valve as part of valve rated capacity. This must be taken into account a predetermined pressure, temperature and time limit. Shutoff classification range from ANSI class 1, where the valve does not require a tight shutoff, to ANSI class 6, where shutoff must be complete or nearly bubble tight. Let us see this 1, 2, 3, 4, 5, 6 shutoff classification. The ANSI class 1 shutoff is an open classification that does not require a test while allowing for a specified agreement between the user and the valve manufacturer as to the required leakage. So, does not require a test. NSI class 2 shutoff is 0.5% of the rated valve capacity and associated with a double ported seat or pressure balanced trims where the metal piston rings and metal to metal seat surface are used. So 0.5% is allowance is providing that one. And the category number 3 shutoff is 0.1% of rated valve capacity and is associated with the same type of valve listed in class 2, but it is used for application the required improved shutoff. So better mean leaking is reducing. It is only 0.1, earlier was 0.5 in class 2. So some other requirements also improved in class 3. Class 4 shutoff is the industry standard for single seated valves, that is important, and metal seating surface which calls the maximum permissible leak is 0.01. Still it is reducing rated valve capacity 0.01. You can note down this 6 classification. To achieve this higher classification with metal to metal seating surface, the load applied to the surface from the manual operator to actuator must certain level. So using the actuator concept also in higher classes of shutoff classification. And class number 5, both NSI class 5 and 6 were developed for throttling valves where shutoff is a primary focus. Very important shutoff classification. The NSI class 5 shutoff is defined by Z, very small leakage, permissible leakage, 0.0005 centimeter square per minute per inch of orifice diameter per second or per square inch PSI differential. See, it is how minute or small allowance is provided in class 5. Class 5 is unique in that it is only classification where allowable seat leakage is allowed to vary according to the orifice diameter and the differential pressure drop. This classification is necessary for those applications where a throttling or control valve is used as a blocking valve that is required to stay closed for lengthy period against a high pressure drop. So it is applicable, 5 and 6 is applicable throttling and control valve. So many reasons are there, and blocking valve is required to stay closed for lengthy period, that is important, against a higher pressure drop. It is applied to a single seat valve with either metal or soft seating surface, that is another, not metal to metal or metal to soft seating, or with the pressure balanced trim that required extraordinary seat tightness. Class 6 shutoff is commonly referred as bubble tight shutoff and is associated with metal to elastomer soft seating, not metal to metal contact. Although with extremely high seating load, it is possible to achieve class 6 shutoff with a metal to metal. It is possible, but with some arrangement inside that one. Class 6 is independent of the pressure differential, but it does take into account milliliter per minute of the leakage versus seat orifice diameter. That means these valves with a large seat diameter applied to a service with a low pressure drop can have a lesser leakage requirement than class 5. So these are the 6 classification of shutoff requirement. Thanks for watching this video. This video, I think, quite large video, taking a little more time, but I have to cover some area of information coming in one section. That's why. So we have understand valve classification based on the different parameter, and valve criteria also. Hopefully we will cover more information of valve in coming videos. If you like my video, then subscribe, like, and push on open the alarm button, so you can ring button, you will get a notification. We are updating in regular informations on various update in our Telegram channel also, so you can subscribe that also. You can join in our Telegram channel. And in the end of the screen, we are added one new feature, giving one previous video or suitable important video plus a playlist. So you can refer according to your requirement. I have arranged the videos in an order, so you can select a suitable video for watching. Thanks for watching this video. Have a good day.